There's just a couple of things I want to ensure you're happy with before I start talking about Pythagoras. And the first thing is squares. If I told you this square had a length of 8 centimetres, would you be able to tell me what the height is? Hopefully you knew the answer was 8 centimetres because the lengths of all sides of the square are the same. If you know one side, you know them all. But what if I was to ask you what the area of this square is? Again, hopefully you know that to calculate the area, we multiply length by width. And in this case, 8 centimetres by 8 centimetres to give us an area of 64 centimetres squared. What's the area of this square? Well, we know one of the sides is 5 centimetres, and in a square all sides are the same length, so we know the height must also be 5 centimetres. We can multiply these two values together to give us 25 centimetres squared. But what if I ask the question the other way around? What if I tell you that the area of this square is 100 centimetres squared and ask you what is the length of the sides? What I'm really asking you is to think of a number that if you multiplied by itself, you would get 100. You may know the answer, but actually this is such an important question, we have a button on the calculator that will do this for you. You may know the answer was 10 centimetres, since 10 times 10 would give 100. But you can use this button on your calculator, the square root button, and that will give you the answer. So just check that you're happy to do that. It's important you can use this button because some squares are very awkward sizes. Use your calculator to tell me what the length of the sides of this square has, and you'll need to give me the answer to say 2 decimal places. Hopefully your calculator's told you that the length would be 8.37 centimetres to 2 decimal places. With all our background information sorted, let's start to look at Pythagoras' theorem. And Pythagoras' theorem only applies to right-angled triangles, and that's just what we have here. When you have such a triangle, I'm going to draw squares on each of the sides. Now the height of this square is 3 centimetres, and so the width will be 3 centimetres since all sides are the same. The width of this square is 4 centimetres, so the height will be 4 centimetres since all sides are the same on a square. We can now find the area of this square. 3 centimetres by 3 centimetres gives us 9 centimetres squared. 4 centimetres by 4 centimetres gives us 16 centimetres squared. Now stand by, because what I'm about to say is what Pythagoras noticed and made him world famous. He said the area of the 2 small squares add to give the area of the big square. Now this looks like the largest square, but if you're ever unsure, the largest square in a right angled triangle will always be opposite the right angle. So Pythagoras said the area of this square is the same size as the 2 small squares added together. So 16 plus 9 would give us an area of 25 centimetres squared. That's all he said. And here's the clever bit. If the area of this square is 25 centimetres, what is the length of the sides? What number multiplied by itself gives 25? And if you're not sure, use your calculator. And you should find that the length of the sides must be 5 centimetres. So there we have it, the answer. So let's just recap. Step 1, draw on your squares. Step 2, write in the area of your squares. All sides are 3, so I can work out the area. All sides are 4, so I can work out the area. Step 3 is Pythagoras. He said the area of the two small squares add up to give the area of the big square. And finally, step 4, we'll use the square root button to find the sides of this square. And we're done. Here's another, and step 1 is to draw on our squares. I'm just quickly going to ask you, which do you think is the biggest square? It's a bit tricky because a couple of the squares look around the same size, so it might be difficult to judge. Don't forget the cast iron method of being certain which square is the largest is look at the right angle, and the big square is always opposite the right angle. So this is the biggest square. Step 2 is to write in the area of our squares. Well, this square, one side is 5, so all sides are 5. And so we know the area is 5 times 5 to give us 25 centimeters squared. In this square, one side is 13, so all sides are 13. And so the area is 13 times 13 to give us 169 centimeters squared. And step 3 is Pythagoras. Remember what he said. The area of the two small squares add to give us the area of the big square. Now, I wonder if you've noticed that in this problem, the big square, we know the area of 169. So the question is slightly different. Remember what Pythagoras said, the area of the two small squares add to give us the area of the big square. So we're going to have to find what this smaller square is worth. Some number add 25 would give us 169. And again, you can use your calculator. 169 take away 25. And that will give us 144 centimeters squared. This is a very common area where students make mistakes because they forget to just check which is the biggest square, and the two small squares must add to give us the big square. And again, if I add these two small squares up, I do indeed get the area of the big square. And finally, step 4, we'll use the square root button on our calculator to find the length of our square. Again, it may be with some of these numbers you know, and if they're nice square numbers, you may know what the square root of 144 is. But often you'll come across numbers that require decimal places. In that case, you'll have to use your calculator. So my advice is just use your calculator, even if you know the answer at the moment, just to check you can use your calculator, the button that find on the calculator, and you should find when you put this into your calculator, the answer is 12 centimeters. And so there again we found the missing length.